Hello everyone, Mr. Schultz here as we dive into Algebra 2, solving quadratic equations by factoring. Make sure that you put your name in the top as well as your period number, and let's go on. So our objective for today is solve quadratics, or more specifically, quadratic equations by factoring. All right, so I'm going to pause the video on the next one and show you what I would do to solve this standard form equation. So let's hold up in three, two, one. So the first thing I'm going to do is I'm going to figure out what is the axis of symmetry. So I'm going to do negative b over 2a, and I get negative 2 over 2 times 1, which is negative 1. And I look right here and I look at the graph and I see, oh, that's pretty self-explanatory because it's already there, negative 1 right here. So every number on the left and right matches up on this quadratic equation. Well, now I know what number I should start with. My x value I should start with is negative 1, and I should go down, and I should go up from there. So let's show the work and come back in 3, 2, 1. So I'm going to tell you right now, it's going to be self-evident what the answers are because they're already here, but are they? Let's talk about it. So if I plugged in negative 1 squared is 1, and then plus negative 2 would give me negative 1. Yeah, that fits right here. The next one, 0. 0 squared plus 0 is 0. All right, cool. 1 squared plus 2 times 1 is 2, so 1 plus 2 is 3. Now, recall, as long as I match up the x values the distance apart, then the y values will be the same. So if I have 1 above, that's going to be the same as 1 below. So it should be 0. Let's see. Yep, 0 right there. And then if I go 2 below, that's the same thing as 2 above. So that's right here. Well, what is my solutions? Well, my solutions are right here, negative 2 and 0. Now, I would have to graph it and then see, hey, look, where does it cross the x-axis? Well, it crosses right there. Let's go on. So what if there's a better way? Now let's factor it. So I could factor this. I could make this y is equal to, well, they both have x's, so I'm going to pull out an x. So if I pull out an x, what times x squared? So let's draw this out. What times what equals x squared? So this is what I have. I have x squared, I have 2x. Well, what times what equals, what do these things have in common right here? Well, an x. So I'm going to write x. So now we just have to think, what goes on top? What times x equals 2x? 2. Sorry, British people. And what times x equals x squared? Well, it's going to be x. So my answer, if I factor this out, my new factored form would be x times x plus 2. Now I want you to think, notice, and wonder, what do you notice about this number that matches up with the solutions that we would figure out? Think about it. We're going to go on in 3, 2, 1. So why would we want factored form over standard form? So factored form is the following. So it's where a quadratic equation has a bunch of multiplication right here. So we have 0 is equal to a times x minus p, the quantity, times the quantity x minus q, where like a cannot equal 0. So what's the reason why we want factored form again? Well, let's go back and look at it. So if I plug in a number, so y is height. if y is 0, what does that mean? If you jump off a cliff, a 500-foot cliff, and you jump and you fall down, and what happens when you hit 0? It's where you crash into the ground. So in this situation, what happens when y is 0? It's where you hit the ground. The x-axis is the ground. So in this situation, what could x be right here to make the equation 0? What times anything equals 0? So the x could be right here. X could equal 0. Well, let's look over here. Well, there's our answer. Let's figure out, what about the other one? What if I make this equal to 0? So if this is 0, this 0 plus 2 is 2, but 2 times 0 is 0, so that's still 0. How about this one? What number plus 2 will equal to 0? Now, what I like to do is I like to write underneath and be like, oh, it's negative 2. Negative 2 plus 2 equals 0. So we have our second answer, our second solution, negative 2. So our solutions are 0 and negative 2. We can read it without having to graph it. We can read it right here and understand, hey, here's my solution. So why would we want factored form over standard form? Well, in this case, go ahead and answer this. I'm going to pause it, you pause it, and then we're going to continue in 3, 2, 1. I love factored form much more than the graphing, the standard form, because then I have to graph it. I can easily figure out what my solutions, what makes, when is my quadratic? The y value is equal to 0. When does it cross the x-axis? All right, let's go on. So informally, it's an equation where everything is a factor. So everything is a factor. So let's write that down. Now, what are factors? A multiplication. Just multiplying. All right, so let's write that in fast. So whatever is multiplying, if you can change one of them to equal 0, then the whole answer is 0. That's it. That's literally it. If there's like 3 different factors, this times this times this, what do you have to do to any of them to make them 0? That's it. That's the work. What makes this 0? That's it. Let's go on. So let's try out a few. I'm going to pause. I want you to try to complete it before I do. So I want you to try to factor number 1 right now. In 3, 2, 1. All right, so here we go. I see that they both share an x. So if I pull this out, I could do the distributive property and understand that x times what equals x squared? X. And what times x equals x? Here's a trick. What times 5 equals 5? 1. There we go. That's it. We're done. Second one. Go ahead and pause. We're going to continue in 3, 2, 1. So on this one, they don't share any x's, but what they do share is a factor of 3. So if I pull out a 3, now instead of doing the distributive method and understand you could multiply this back out, you'll see this kind of looks like the FOIL method, but not yet. So what I'm going to do is I'm going to put this in the box. 3x squared plus 12. I know they share a factor of 3, so I'm going to pull out a 3. 3 times what equals x squared? X squared. 3 times what equals 12? Positive 4. So now I have my factor. I have 3, and then I have x squared plus 4. That's it. Next up. Now, technically we haven't factored everything out, but we're just doing some basic factoring, okay? So let's go on. We have this 3. Problem 3. Pause it in 3, 2, 1. All right, so I think they both share a -5. And how many x's? I have four here and 3 here. So they both have at least 3. I'm going to put an x to the third power. Now, what times what? I pulled out a -5, so then this should be positive. And I pulled out all of them but 1. So now this is x. So a negative times a negative is positive. So if I pull out a negative, this should now be plus. And if I divide by 5 and I divide by x to the third power, I should have 3. There we go. We're going to go on in 3, 2, 1. So we're just doing some basic factoring, basic pulling it out. So let's go on. All right. Fun with multiplication grids. Now, you can see that on one of them, I used a multiplication grid to figure it out. But let's show you them. I'm going to have to set it up. So what I could do is I could show you how this gets rewritten. I'm just going to write this out. So I have x squared, and I have a plus 4 right there. And then over here, here I should have a -5x to the third power. And then up here I have x, and there was a plus 3. So now if I actually show this, if I was able to pull it out, I divided, I'm going to go back and multiply and show you. So if I have this, what I'm going to see is I can quickly put it back into standard form. So x times x, x squared, 1 times x, x. So this is x squared plus x. The next one right here, we have 3 times x squared, so 3x squared, plus 3 times 4 is 12. So this is 3x squared plus 12. This one is a little bit harder. Negative x to the third power times x to the fourth power. First power. How many x's are there? 1, 3, and then a 1 makes 4. So now this is x to the fourth. But wait, how many numbers am I multiplying? By -5, so I get -5. And then -5 times 3 is -15. But wait, there was that x to the third power, so I'm going to put it right there. All right, let's go on. Let's try a slightly tougher one. And we are trying the multiplication. We're trying to go back into standard form, but don't worry too much. I like factored form anyways. By the way, before we do anything, understand that the solutions to this form right here would be -2, and let's see if you get it. What do you get it? And -4. All right. But that's not what it's asking. It's asking, hey, let's multiply back out. So what I get is, I can write it like this, x plus 2, and I have x, and then I have plus 4, and now I can multiply it out. I multiply just like a multiplication grid. X times x is x squared, x times 2 is 2x, x times 4 is 4x, and then 4 times 2 is 8. Now I just need to add them together. Remember, you can't add things that are not the same. Can only add the same thing. So like 4 hot dogs plus 1 puppy isn't 5 hot dogs. I don't want to go to that barbecue. So right here, I can only combine these. These are the only things that are the same. So my solution would be 0 is equal to x squared plus 6x plus 8. Well, what am I trying to do right here? I want you to see that we can multiply these factors to get a trinomial right here. Try to figure out that, hey, we can also go the other way. So let's do that. So remember with your diamond problems, like if you see this right here, you have a 6 and -4. This is multiplication right here. This down here is addition. So 6 plus -4 is 2, and 6 times -4 is -24. So if I look right here, I have 8 and 6. So I might go, all right, is it 1 times 8? Well, that works up here, but 1 plus 8 is 9. That doesn't work. Then I'd be like, all right, what plus what? Well, what about 3 times 3? Well, 3 plus 3 is 6, but 3 times 3 is 9. That doesn't work. So you kind of have to like go through your head and be like, all right, what makes this true and makes that true at the same time? Well, what about 2 and 4? 2 times 4 equals 8, yeah. What about 2 plus 4? And there you go. It's equal to 6. So we figured out our solution. So I kind of like doing this a little bit. Now, it's okay. I'm going to give you a little problem right here. How about this? 1/2 and 1/2. What times what? 1/2 times 1/2 is what? So 1/2 times 1/2 is 1/4. And then 1/2 plus 1/2 is 1. So if I give you something like this, where there's a fraction, you have to think about, what are the rules of multiplying fractions? All right, let's do a different one, but let's give you the top and the bottom. So I'm going to give it to you in just a second. All right, what times what equals -9? And what plus what equals 0? Pause it, and then let's figure it out before we come back. 3, 2, 1. Well, what times what? 3 and 3. But one has to be negative. Now, if I add those together, will they equal 0? Yeah. So what does this mean? Well, let's look at the middle one right here. You see that we got the answer of 2 and 4? Well, watch this. Our answer 2 and 4 is literally from right here. We have a 2 right here, and we have a 4 right there. We understand that if you multiply these out, if we did the FOIL method, you understand 2 times 4 is 8. So that's this. Let's show you what that looks like. The FOIL method looks like the claw. When we multiply the outsides, it's equal to 8. But when we multiply to the insides, 2 times x and 4 times x, what happens is it creates this 2x plus 4x, and it gives us 6x. That's this red part right here. That's what we're adding together. So what do we what multiplies to 8 and adds to 6? 2 and 4. And so then we can take those numbers and factor out our equation. Find our quadratic in factored form. Let's go on. So now let's actually factor them. So what I'm going to do is I'm going to want to pull this so to make it equal to 0. So if I minus 18, I should get x squared minus 6x minus 27 is equal to 0. Once I pulled everything to one side, now I'm going to figure out what times what equals -27 and what times what equals -6. Okay, well, what about -9? -9 and -3? Well, -9 times -3 is positive 27. So that won't work. What about -9 and positive 3? 9 times 3 is 27. Well, negative 27. What about -9 plus 3? -6. Now, a lot of times we might go -3 and then have a positive 9 and then realize, hey, that works for the top. But all of a sudden, hey, it's positive 6. If you see that and you're like, wow, I just need it negative. What can I do? Switch the negatives. Make the 9 negative instead of the 3. So I have -9 and 3. So what this turns into, let's see if you get it. Let's pause it. 3, 2, 1. What this would look like is this. X minus 9 times x plus 3 is equal to 0. So my solutions would be 9 and negative 3. That's where it hits the x-axis. Now I want you to try this one right here and go from there. I'm going to pause it twice. Let's see if you can get the set it up, set up that diamond problem, and then 2, solve it. All right, what multiplies to negative 6 and adds up to 1? Let's see if you got it. All right, it's 3 and negative 2. Now, let's make our factored equations. Go ahead and pause it. And here we go. So here we go. Here's my factored form right here. X plus 3 times the quantity x minus 2. What will this mean later when we're actually solving the factored forms? Later, we're going to solve and say, hey, our solutions are negative 3 and 2, because what do we have to do to make any of this 0? Because anything times 0 is 0. All right, your last thing, what I want you to do is I want you to explain this lesson in 12 words or less. All right, guys, I'll see you in class, and I hope you have a wonderful day.